So here we have moving to our next theorem, theorem 2. Hope you have understood theorem 1. So now we are going to discuss theorem 2, the very famous. This is actually the Pythagoras theorem. We have done lots of application in your previous standard, right? But we have done the application. We don't know the proof of Pythagoras theorem, that square of the hypotenuse is equal to the square of the perpendicular plus square of the base. So here we have going to prove the Pythagoras theorem with the concept of similarity which we have discussed earlier. So let us prove Pythagoras theorem. So what we have in theorem 2, it is nothing but a Pythagoras theorem in statement. Just read once, you will understand. Here what we have, in a right triangle. Right triangle means a triangle. In a triangle, if there is one angle which is 90 degree, that triangle is known as right triangle, or we simply call it right angle triangle. Now in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. We know in a right angle triangle that other two sides are base and perpendicular. So you know this theorem right before, and we have done lots of application of this theorem, but we are not in the previous standard. We don't know its proof, but we have its proof now with the help of the concept of similarity. Now see, here we have a triangle ABC. Read the given property. Here what we have, here we have a triangle ABC, and it is a right angle triangle. And where it is right angle? Right angle at B, right? That means at B there is 90 degree. So what we are required to prove? We are required to prove that square of AC, we know if there is a right angle, this is the right angle. So that means this is base or this is perpendicular, and this AC will become hypotenuse. So here AC square is equal to the AB square plus BC square. This is what we are required to prove. That means hypotenuse square is equal to perpendicular square plus base square. So we have done lots of theorem, and we know while proving theorem we need construction also. So I have used construction here, and what we have here, BD is drawn. What is BD? It is actually a perpendicular. So BD perpendicular on AC is drawn. Okay. Now see, as we have discussed earlier, this triangle in our previous theorem 1, we have discussed that this triangle, the shaded triangle ADB, is similar to the triangle ABC. We have discussed in the previous theorem. So I have just written that these two triangles are similar, but when in your exam this theorem will come, if it will come, and if it is asked you to prove this theorem, then in that case you are not able to write this directly. You need to prove this. You need to prove this till here, and you know how it can be proved, because we have discussed in the previous video. Now, so I have just written that they are similar. So as they are similar, we know by the concept of similarity, when two triangles are similar, then their corresponding sides must be proportional. So write the corresponding sides, like AD divided by AB. You know the correspondence, right? Here A correspond to A, D correspond to B, and B correspond to C. These are the correspondence of the similar triangles. So AD divided by AB, DB divided by BC, and AB divided by AC. I have written all the corresponding sides. Now let's see where you are getting a square of the sides. From where you are getting? From to equate which two we will get a square of the side. See, if we equate first one with the third one, see, if we equate first one with the third one, then we will get square of AB. So I implies AD by AB equals to AB by, so I have taken this and this, so that I will get square of AB. So after cross multiplication we have equation 1. Now similarly, this triangle, this shaded one, triangle ADC, is also similar to the whole triangle which I have told you in my previous video, that it is similar and with this the same concept you can prove this also. Let us discuss also how this triangle is similar, as this angle and this angle both is 90 degree and angle C is common, that is why they are similar. So as these two triangles are similar by angle rule, same thing I have done, I have written their corresponding sides. As the two triangles are similar, then their corresponding sides are proportional. So I have done the same thing here also. Now see, by equating which two, we will get square of the sides. See, if we equate the second one with the third one, we will get square of the sides, square of BC we will get. So implies I have taken this two. After cross multiplication, we have equation 2, right? Now what we will do, according to the proof, AB square plus BC square we need. That is why I have added equation 1 and 2. I have added equation 1 and 2. See this. So in LHS there will be AB square plus BC square. In RHS there will be AD into AC plus DC into AC. See here AC is common. So I have taken AC as common. So what is left? AD plus DC. What is left? AD plus DC. A to D plus D to C. So what is that then? AC. We can say AD plus DC as AC. So AC into AC give you AC square. So AB square plus BC square equals to AC square. This is what we call it as Pythagoras theorem. And today we have proved with the help of concept of similarity. I hope you have understood this theorem.